In this example we consider Newton's cradle, and we say that if sphere 1 strikes sphere 2 with velocity v1, find an expression for the velocity vn of the nth sphere, and asks the question, where is the energy lost? So you have the first particle comes down and hits, falls from this height as a pendulum to this position here, at which point it collides with particle 2, which then collides with particle 3, and so on. And we consider the situation just before and after the collision. So just before the collision, the first marble or particle has a speed u1, whereas the second one is stationary. Then after the collision, they have these velocities v1 and v2 respectively. Now, given that the total momentum is conserved, we can say that mu1 is equal to mv1 plus mv2, or we can say that v2 is equal to u1 minus v1. Now, introducing the idea of the coefficient of restitution, we can say that the energy lost in the system is a ratio of the speed of separation divided by the speed of approach. So the speed of separation is v2 minus v1, v2 moving away from v1, and the speed of approach is u1 minus 0, so it's u1, so it's coming towards 2 before the collision at a speed of u1. So, rearranging this equation, we get v1 is equal to v2 minus e u1, and combining them we can say that v2 is equal to u1 brackets 1 plus e minus v2, or v2 is equal to the fraction 1 plus e over 2 times u1. So that's a way to relate the initial speed coming in, u1, to the final speed of the second particle, u2, as a function of the energy lost in the collision. Now similarly, we could say that if the collision exchange is now between 2 and 3, you would have v3 is equal to 1 plus e over 2 times v2, and v4 is equal to 1 plus e over 2 times v3. Or you could say that you could start substituting in v2 the expression here, and then expression v3 into this expression, and you could say that v3 is equal to 1 plus e to the power 2 over 2 times u1, or more generally vn is equal to 1 plus e over 2 to the power n minus 1 times v1, always relating it back to the final speed. And this is the answer to the question, and so this tells us the speed of the nth particle with respect to the initial speed v1, which actually should be u1, and the question says where is energy lost? Well, energy is lost here. If this is 1, i.e. a perfectly plastic collision, then this becomes 1. This 1 plus 1 is 2, divided by 2 is 1. So when this is slightly less than 1, as it will be, even in a near frictionless environment, then the energy is going to be lost from that.